हेलो मेरे प्यारे बच्चों, कैसे हैं आप सभी? वेरी गुड मॉर्निंग टू ऑल ऑफ यू. एंड इफ यू टॉक अबाउट द रोटेशनल मोशन, ट्रांसलेटरी मोशन, वी कैन यूज second law of motion. It is the net force. Net force applied on any body is equal to the rate of change of its linear momentum. For translatory motion, external force applied on any body is equal to rate of change of its linear momentum. It is the second law of motion, Newton's second law. Okay. Same concept we can use for rotational motion. So, second law of motion for rotational motion. For rotational motion. For rotational motion. So, what should be this second law? It should be the external torque applied on any body should be equal to rate of change of its angular momentum. Okay. External torque applied on any body is equal to rate of change of its angular momentum. Okay. It is the second law for rotational motion. But what will happen if this external torque is equal to 0? If we are not applying any kind of force, external torque on body, then you can say this change in angular momentum is equal to 0, means L vector is equal to constant. L vector is equal to constant, means initial L is equal to final L. It is called conservation of angular momentum. It is called conservation of angular momentum. So, what is the law of conservation of angular momentum? In this lecture, we are talking about law of conservation of angular momentum. So, the title is law of conservation of angular momentum. Law of conservation of angular momentum. Okay. What is this law? If we are not applying any kind of external torque on the body, okay, the external momentum remain conserved. Initial angular momentum is equal to the final angular momentum. It is the concept of conservation of angular momentum. Okay, very easily we can understand, and we can use so many kind of example also to understand this concept of conservation of angular momentum. So, let us see. So, my dear students, if you talk about the conservation of angular momentum, we can take so many kind of example. One example is, let us consider a circular platform, okay, and this platform can freely rotate about its axis, having moment of inertia I, okay, and initially two balls of mass mm are placed at the center of this circular platform, and if this circular platform start rotating with initial angular velocity omega naught, then what will happen? This two ball will move away due to the centrifugal force, okay, move away from the axis of rotation. Let us consider some canal, some groove in which this two ball can move. Okay. So, when these two balls will reach up to the circumference, up to the rim, what will be the angular velocity? This angular velocity will change because of the conservation of angular momentum. So, when balls reach up to circumference, find angular velocity of circular platform. Okay, what will be the angular velocity? So, we can use conservation of angular momentum. Conservation of angular momentum. L initially is equal to L final, means I1 omega 1 is equal to I2 omega 2. Okay. So, what is I1? It is I, since these two balls initially at the center. So, the moment of inertia of these two balls will be equal to 0. Okay. So, only we have to take moment of inertia of circular platform. So, I1 and speed is omega naught is equal to I2 is I plus 2m r square. Why? When these two ball will be at circumference, the moment of inertia about the axis will be m r square, same as it is for second ball. So, it is 2 m r square. So, the moment of inertia of disc plus moment of inertia of balls into omega. Okay. So, omega will now I divided by I into omega naught divided by I plus 2 m r square. Okay. So, it is an example of conservation of angular momentum. Okay. Example of conservation of angular momentum. We can take so many kind of other example also, like if a rotating doll carrying two dumbbells in her hand. Okay. Now, if she stretch her hand, so what will happen? Moment of inertia will increase, angular velocity will decrease. Okay. So, all these kind of example are conservation of angular momentum. Thank you.